Namaste. This is the assignment 1.2 of Verilog under the Agimus Technology in the Xilinx Spartan 6 platform. And here we are going to build the 3:8 decoder. So from the scratch. So for that, first I'm going to open the IC 32-bit and here, okay, ISE. Now, first of all, what is this 3:8 decoder means? We are going to, okay, I'm going to show that. So here we are going to have something like this. It has the 3 inputs and one the enable active high or active low. Now I'm going to consider this as a active high. Okay. Then from the 3 input we are getting the output of 8. Okay, here we have to write a 3:8 decoder IC number. Then here we can see that the table. For example, if I give 0 0 0, then I'm going to get the output as 1 0 0 0 0 like that. So this is my input LSB and the MSB. So if I give the input like this, I'm going to get the output here with respect to this input from Y0 to Y7. So 3:8 decoder. Okay. So in order to implement this is what this thread table and output. Here we can see this is the output for Y0 and Y1, Y2 like that. So in order to get the output Y1 as Y0 as high, we just need to do I2 bar, I1 bar and I0 bar. Similarly for remaining all those things. Okay. Then we will start building this from the scratch. So here I'm going to file and the new project, and here I'm going to give the name as 3:8 decoder. Okay, 3:8 decoder. And here I'm using the Spartan 6 and XC6 is the model that I showed in my first video. Okay, then click next and click finish. Now we are going to write in the Verilog. So here right click on it and the new source, and here just choose the Verilog module. Here we are going to write our output functions, and here, okay, file name, this I'm going to give just 3:8 decoder. Okay. For input, I have 3 inputs and one enable input. So what I'm going to do means, in this these 3 I'm going to select as the input. So we can just give the input by using this push buttons, and enable, for that I'm going to use this one. Okay, this DPI switch for the enable pin. Okay, enable is not required, but anyway we are going to design that enable. So what we have to do means, these 3 are the input pin. Okay, then output for 8, these here are the 8 LEDs that I'm going to use for those output things. So 3:8 decoder that we are going to design now. So for that, here input, I'm going to use this as okay, I0 and I1, I2. Okay, 3 input and one enable. Okay, EN, I'm going to call that as EN, and these 4 are the inputs and output. So for that, Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Okay, 8 outputs. This we have to just change this to the output. Okay. Output. Okay, this one put and this one output. Okay, 1 2 3 4 5 6 7 8 are outputs. Okay, just we can clarify that input and remaining things are the output. Now yeah, here we have that. So now what I have to do means yeah, I just changed that to the gate level modeling, that default code to the data flow to the gate level modeling. So now changing means that I declared here all these things and input and the output. And now what I have to do means why not, we just need to assign all these outputs to the that particular operation that we have that here. So why not is I2 bar, I1 bar and I0 bar. That means it is going to end with these three. So what I have to do means why not okay, this is the gate level. So I just need to do the AND operation, AND off, and here the output is Y0 and input we have to provide. So for that it is yeah, what is this here, it is there, not here, yeah, here I2 bar, I1 bar and I0 bar, but here only I0, I1 and I2 is there. So we need to create the wire. That means we require that into intermediate state. So wire, okay, WIRE, and here I want I0 bar and I1 bar and I2 bar. Okay, then here we are assigning the NOT operation to get the, okay, it is I0 bar, okay, I0 bar comma I0, and similarly I'm just going to copy paste this. Okay, here it is I1 bar and I2 bar. So here it will going to take I2 and I1. I think you've understand this. So going to the NOT operation, then AND off, Y0 is the output, and we just need to do okay, I0 bar and I1 bar and I2 bar, because here we have that, here we can see I2 bar, I1 bar and I0 bar. That same thing I did here, I2 bar, I0 bar and I1 bar. Okay, yeah, we'll just change it to same way. It doesn't matter, but we'll just change. Yeah, it is one only. Here it has to be 0. So I2 bar, I1 bar and Y0, I0 bar. Okay, then similarly we need to do the AND operation for all these equations. That means Y1, Y2. Similarly here I2 bar, I1 bar and I0. So what I have to just use here means okay, I just copy this and this my Y1. So here Y1 and I2 bar, I1 bar and I0, not the bar, because I0 is this directly taking from this input. Okay, I0, we're not using this wires here. Similarly we need to do for all Y2 till Y7. Yeah, I just filled the same thing for the remaining one also. Here we can just see it is 0 1 0 1 0 1 0 1, then 0 0 1 1, like that we need to fill. Yeah, I forgot one thing, that is the enable pin. So here I forgot to write here also. You just had to add enable here, because we just E into E, so that we just forgot here. So what I'm going to do means here just add that enable pin. So enable is EN. Okay, I'm going to just add that to all the things, EN, and here also EN, and here also EN, and EN, okay, and EN, and comma EN, and here comma EN. Okay, now yeah, this is what we want to get. Why not is the, yeah, this is what the thing we require. Now we just need to just type Control S. If any error it will there, it will going to show. There's no errors. Yeah, now we need to add the RCF file. Okay, so for that yeah, new source, I'm going to click, and here we can see implementation constraint file. Okay, uh, okay, then I'm going to add this. The name is uh, just type 328. Okay, 328 decoder. So yeah, so for our first of all, for the inputs, what I just told means yeah, here, okay, it will going to come, it will going to load a little bit. Yeah, these three we are going to use as input. That means yeah, input, that is ABC. Then here these are all the 8 LEDs, that is 3:8 decoder, and this one we are going to use this as a enable pin. So first of all, I need to use these three. Okay, so for that, here I have that. Where is that? Yeah, here I think. Yeah, so here. Okay, so push buttons. I want to add the 3 push buttons, so just copy this, and here if we see what is its yeah, not here, it's here. What's its name? It is I0, I1 and I2. Okay, I0, I1 and I2, and here we can see I0 is the LSB. Okay, I0 is the LSB. So I'm just going to assign this LSB to the button 3. That means here we can see that this is my LSB, and this I'm going to make this as a MSB. So I0 is the LSB. This I have to make it as I0 because it is the third button in the series. So I0, I1, and this one is the I2. Okay, now this follows like this is I2 and this I1 and this is I0. Okay, this is I0. Okay, yeah, this one I0. So for that, yeah, here we have that it is I0 is the LSB. Then okay, this is for the input, and for the enable pin we need to use this DIP switches. So for that, this one, first one. So yeah, this is for EN. Okay, this to the input, enable, and the next one is the for output we need to use all those 8 LEDs. So for that, here we have that okay, here I have that LED. So all these 8 I'm going to just copy, and here we just need to, this is my Y0, and this is Y1, and this is Y2, Y3, Y4, Y5, Y6, and Y7. Okay, then I just save this. I think we created all these pins. Yeah, now I'm just going to generate the program file. If any error is there, it will going to show now. Synthesizing, it takes some time. Let's see. Yeah, it's generating the program file at the final step. Yeah, it's successfully generated. Now what we have to do means we need to add this program to the device. The device is connected. Okay, here I think it's visible. So this boundary scan, and here initialize chain. So here we have to see that, yeah, here Agimus, and we are seeing this. So do you want to, yeah, I need to assign this bit file, and the name is 3.8 decoder. So 3.8, where is that? Okay, yeah, it is here. So this bit file I'm going to add, and I added this one. I just need to give no, and okay. So here just click on this. Yeah, it just select it. Okay, then just program it. Now here we can see the program success. Okay, now now we will going to check here. This is my enable pin that I'm going to make this as 1, and wait for it. Yeah, we looked something strange. It not worked. Why? Because this program is correct. Okay. Why? Because in this UCF file we used here before, those what's that, push buttons. But in this push buttons, I think it will not going to provide the logic 1 as the, when we press it, it will not going to provide logic 1. I think logic 1 for the LEDs like that. So what I did means I just changed these from these push buttons to the DIP switches. So for here we can see this is for the enable. I use the DIP switch 1, that is this one, and remaining 3 I used for, this is for I2, and this is for I1, and this is for the I0, like that I used. You can check with this once whether it will work or not. In my case it not worked for these push buttons, so I just changed this to the DIP switches. Now it's working fine. Only the slight changes I did is I just added these 3 lines from that DIP switches, and now I'm going to generate that file. Yeah, it is just now I generated that in order to check, and now I'm going to add this. So manage configuration, and here we just need to add that. Okay, initialize chain, and yeah, here we have okay, yeah, okay, and this one no, and here we just need to right click, and we just have to program. Yeah, now it's programmed, and here we can see that here now if I, okay, now here we can see this one is the enable, and 2 is the I2, I1 and I0. Okay, I0 is the LSB, and this one I2 is the MSB. So now this is 3:8 and 1 is the enable. So here no LEDs are glowing, that means my enable pin is at 0. So I just have to make this enable, yeah, I just made this enable to 1. So here we are getting the output in the Y0. Okay, this is the Y0. So here 0 0 0, so it is Y0. I'm going to just make 0 0 1. So yeah, now the LED changed from 0 to Y1. And similarly, if I make this as a 3, then here you can see LD2 is skipped and this is 3. And now if I make okay, yeah, I just want to 1 1 1, that means 7. So here Y7 is glowing. So 0 1 2 3 4 5 6 7, yeah, it's the 7th LED which is glowing starting from the 0. So if I make yeah, if I make 4, now we can see, okay, I just need to this one and this one. Yeah, now you can see 0 1 2 3 4, 0 1 2 3 4, yeah, 4th LED is glowing. This is what we can see from here. The same thing, this it is following this logic table. Okay, this logic table only it will going to follow. I think you've understand about this. Thank you.